In this lesson, we're going to look at how to use opaque types in Scala 3. And the text for this lesson comes from the second edition of the Scala Codebook, and I call this recipe Creating Meaningful Type Names with Opaque Types. And I start with the problem statement that in keeping with practices like domain-driven design, you want to give values that have simple types like string and int more meaningful type names to make your code safer and easier to read. And perhaps I should have added not just domain-driven design, but other practices like functional programming as well. So in Scala 3, the solution is to use opaque types, and this is something that's new in Scala 3. So the way I introduce the problem is, if you imagine that you have a method like this, add to cart, and it takes customer ID, which is an int, and product ID, which is also an int, and this method could be much larger and take more parameters. They could all be ints or whatever. But if we just look at these two, it's possible that because both are ints, it would be possible to confuse them. So then the question becomes, if you call them, are you making sure that you have the right ID or the right integer right there? And in Scala, the solution is to create these custom types as opaque types. And I have a complete solution here. Let me scoot this over so we can start working a little bit. So now let me copy this code right there and paste it in here. Oops. So this solution has a couple parts to it, and I'll start with this block right here. So I start off with this customer ID is the new type that I want to use. So where I was using int before, instead of using int, now I want to use customer ID. So this is a new type that we're creating. And then in this line where I have object customer ID and then the apply method, this is actually creating a companion object right there. Therefore, this is essentially our constructor. So we say that we're taking in an int and then we're transforming that int basically into a customer ID is what that is. So this is actually the entire body of the method right there. And then finally, this can equal line here is a way for us to define that we want to be able to compare two different customer ID values to each other. And then here, product ID follows the exact same script. And this might have been a little bit different. Like if this was a string or person or some other type right here, this code would look a little bit different. But because I'm transforming both of these types from an int type here into a product ID in this case and into a customer ID in this case, the code actually looks very similar to each other. And now I'll just scroll down over here. So now we'll get rid of that and we'll say what you want to do is you can import domain objects. And I should have used dot star. That's the new way to do it in Scala 3. Instead of the dot underscore was something we used in Scala 2. You can still use it in Scala 3, but the preferred way is like that. Then I can create a new customer ID and say that is equal to a customer ID. What do I pass in? 101 there. And then the new product ID equals product ID, and we'll make that one 101 also. And now if I had an add to cart function, you would see that I would define it like this. I would use customer ID and product ID like that. So we can actually just copy those there. And because I'm not going to use this function, I can just define it like that. And one thing I want to do actually here is clean this up a little bit. So I want to be clear that domain objects ends. So I will say end domain objects right there. Then I want to move this import and put that here because I'm going to need that code in this function and down here. Tighten that up, move that down, and then def add to cart. What I will do for this one is just format a little bit differently for our reading. And then here I can say, well, colon, and I don't care what this method does right now. We'll just give it the 3 question marks like that. And the only thing I'm trying to show here is that when you pass these values into add to cart, you can actually treat these customer ID and product ID as types, just like if you had created something like class customer ID and handled everything that way. And then now that we have this function add to cart, what we could do is say, well, I want to call add to cart and pass in the customer ID and the product ID. And you see those error messages go away. Important part to note here is that if I had put in like 101 right there, you see that error come up right away. So this function is clearly trying to take in customer ID and product ID and not an int type right there. And then the other thing I want to show is if you try to compare customer ID to product ID, then let me scroll that up and then say that, then I could say they are equal. And if I save that, we'll come over here and we'll see the error message over here. One thing I want to say is that this code is in the package opaque types, and then the two opaque types I have are inside this object called domain objects. So that's why you're seeing some other things over here like opaque types and domain objects. But the essence of this error message is that customer ID and product ID cannot be compared, period. They can't be compared with equal, or not equal to. And that's because these are truly two different types here and here. And then also can equal controls what these types are allowed to be compared to. So here I'm saying that customer ID can only be compared to other instances of customer ID, and product ID can only be compared to other instances of product ID. That's a way you can read this entire line right there. But anyway, this not compiling is exactly what I want, so we get rid of that. And I'm also getting error over here, and that's because add to cart is not implemented. So if I just said something over here like print line hi, that error message should go away. And then we see that hi right there. And if you've never seen that before, when you have a method defined with 3 question marks, this is perfectly legal Scala code. You can do that until you call it like this. Like if this didn't exist right here, that code would be perfectly legal. And I often do that when I'm first thinking about functions and I don't want to worry about the body right there. I'll just be like, well, I don't worry about that yet. I'll just put that right there and then I'll deal with that later. But problem is when you come over here and actually call it, then you'll get that exception. And that is the not implemented error. And implementation is missing. And indeed, that implementation is missing right there. So let me either comment that out or just delete that. Or let me do it like this, like I had it. And then in the discussion here, I start talking more about domain-driven design. And one of the goals of domain-driven design is that the names that you use for your type should match the names that are used in the business domain. So when you think about it, a domain expert thinks about things like customer ID, product ID, username, password, social security number, credit card number, etc. And conversely, they don't think about Scala types like int and string and double, float, big decimal, etc. And then in this area here, I note that another important consideration is if you get involved in functional programming, one of the really great benefits of functional programming is that programmers should be able to look at your function signature and see exactly what a function does. So a simple example of that is that if you have this function f and it takes in a string and it returns an int, you don't know anything about the function body over here, but just by looking at that function signature, you can tell that if we're using functional programming practices, there's only a few things that this function could do. So it could determine the string length. It might calculate the checksum of the string. It might count all the lowercase characters in the string or count all the uppercase characters in the string, something like that. But specifically, it can't do something like be a make int function, because if you try to convert a string like hi mom into an int, that's going to throw an exception. And if you do that, this type right here cannot be int when you're writing pure functions. Because it would throw an exception, this type would have to be an option of int, a try of int, or an either with these two types, throwable and int. And again, that's only true if this is a pure function, so that's why I'm mentioning functional programming. And as I scroll down here, as I note, because pure functions are so important, we also don't want to write types like this. So I don't necessarily want to write username string, email string, password string. Instead, if we go through this process of creating these opaque types like we have here and in this other block down here, if we go through that process, we can have much more meaningful type names like username, email address, and password. And when we do that, a benefit is that we can't get these in the wrong order. So these you could possibly get in the wrong order when you're calling, although hopefully an IDE would help you. With this approach, you'll get even more help from an IDE because there's no way you can get these mixed up, because you would not be able to pass an email address into a username or a password into a username, etc. More important than that is that the type signature is going to be much more meaningful to other programmers who look at this. And now they can say, oh, okay, clearly you're taking in a username type here, an email address type, and a password type. So to me, that's more meaningful to other programmers. Another nice thing that I don't show here is that you could add validators to these types. So we could validate each of these as they're created. And then as I note right here, by deriving can equal when we create opaque types, you make it impossible for other types to be compared. And as I mentioned, this line right here is the Scala 3 way of saying that I only want to allow product IDs to be compared to other product IDs. I don't have customer ID here, for instance, or I don't have more code in this section that would allow me to compare a product ID to a customer ID, because at least in this case, that just doesn't make sense. And similarly, I have the same approach here. And again, if we look here, the last statement is that your code more accurately reflects the verbiage of the domain. So that's more of a domain-driven design consideration, but I think it's a good consideration too. As I scroll down here, there are several benefits of this solution. So one thing I note right here is you could actually just create an opaque type with just one line like that. But in practice, I found that's not really a good idea. Like when you're working with a much larger application, you're going to want to have these other lines in there. So that's why I started with this as being the main recipe instead of starting with something like this one-liner being the main recipe. This approach right here would only make sense if you're writing a really small application. So I believe I covered this already, but the benefits of this three-step solution are that the opaque type declaration right there creates this new type named customer ID. And then as a note here, behind the scenes, inside of your code, you can treat the customer ID as an int, but everybody else in the outside world is going to have to work with customer ID. And then this object right here, that is a companion object. And basically what it does is it transforms the int that comes in into a customer ID that comes out. And that you can see being put to use right here. When I put this 101 into the customer ID right there, it's actually coming into this apply method right here as an int. And then it comes out of that function as a customer ID. So if I hover over this, you'll see that that is a customer ID right there. So that was the object with the apply method. And then the given can equal declaration, which I have on this line here, and then this other line down here, limits the types that can be compared to each other. And in large applications, that's a really nice win. I also want to mention that I covered can equal in another video, so I was going to get into that more here, but I'll just recommend that you see that other video. And that other video is on multiversal equality in Scala 3. And if you're interested in the history of opaque types, there were several attempts to achieve similar solutions in Scala 2 that included type aliases, value classes, and case classes. And unfortunately, all of those approaches had weaknesses as are described in the opaque types SIP. So if you take a look at this URL right here, you'll see this goal right there. And that was that operations on these wrapper types must not create any extra overhead at runtime while still providing a type-safe use at compile time. So these other approaches could not meet that criteria or that goal, but opaque types in Scala 3 do. There are a few rules to know about opaque types. So they have to be defined within the scope of an object, trait, or class. So that's why I put them inside of an object in our example. And then the type alias definition is visible only within that scope. So what I mean by that is within that scope, your code can see that customer ID is really an int over here. But outside of here, nobody else can see that. All they can see is customer ID and product ID. And that's actually the third point here, is that outside the scope, only the alias that we create is visible. So again, outside the scope, other code cannot tell the customer ID is in fact really an int. And lastly, I noted from the SIP that operations on these wrapper types must not create any extra overhead at runtime while still providing this type-safe use at compile time. So there's a difference between runtime when the application is running versus compile time when we're writing code and compiling it. So what they say right here is that opaque type aliases are compiled away and have no runtime overhead. So again, this is something they were able to achieve in Scala 3 with opaque types that they couldn't previously achieve with these other efforts right here.